Hello, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in advanced functions, and it's a by request video as you study for your final exam. And let's look at the question. The question I was asked to do was number 1 from the review that I handed out. And here's what it says. It says when this function, f at x, here it is, it's a quadratic. So when f at x is divided by x minus n, the remainder is 2. Find n. So what we clearly have here is a polynomial, and we're dividing by another polynomial. So therefore, I put here just a review of the remainder theorem, and the factor theorem because it's connected. What the remainder theorem says is that when you have a function and you divide by a binomial like this, x minus b, the remainder produced, so when you do that division, you're going to get a quotient and a remainder. The remainder that you get is the same value as if you subbed b, here's the b, directly into the function. So if all you're interested in is the remainder, you don't have to do any long division or synthetic division. All you have to do is do a substitution, and that's the situation we have here. We have a function, we're dividing, but the only thing we're worried about in that division is the remainder. So we're going to be using the remainder theorem. And I put here just as a consequence of the remainder theorem, the thing we use a little more often is the factor theorem. And so just quickly, when you divide a polynomial f at x by x minus b, if you get no remainder, and remainder 0, then what you've done is you've found a factor, and that's the start of the factor process. And of course, we use this fact and we sort of turn it around, and we say that if f at b equals 0, then binomial x minus b would be a factor. But to answer this question, we only need the remainder theorem. So let's go ahead and look at this again. So there's the question. We have a polynomial f at x, and we are dividing by this binomial x minus n. We're told that the remainder is 2. So according to the remainder theorem, if I substitute n into the function, so again, the remainder theorem says that if you have a polynomial x minus b, and you're dividing f at x by that polynomial, the remainder you get is the same as if you did f at b. So I'm doing the same thing here. I have x minus n, so if I find f at n, I will get the same remainder. So f at n would be 2 to the n squared minus 7n plus 5. So if I sub n into this polynomial, I will get the remainder of 2. So the remainder of 2 means that I can sub that in. And now what I'm left with is just algebraically a quadratic, and I need to solve for n. So let's go ahead and do that. So I have 2n squared. Oops, I put an extra squared there, my bad. Hopefully you caught that. Make it equal to 0, so I can try factoring or using the quadratic equation. So plus 3. So I just need to factor. So however you like to factor, go for it. I'm going to use good old-fashioned decomposition. Ooh, the pen just messed up. So two numbers that multiply to positive 6 and add to negative 7 would be negative 6 and negative 1. So those are the two numbers I'm going to use for decomposition. Common factor, 2n, n minus 3. Common factor, well, there's not much in common, so I'm going to common factor negative 1 so that I can create this beautiful shared bracket, which now becomes my common factor, and then what's left would be 2n minus 1. And therefore, I can solve for n by saying that n minus 3 equals 0, so n must equal 3, or 2n minus 1 equals 0, so n must be a half. So those are my two answers. N must be 3, and n must be a half. Okay, so again, that was a remainder theorem question. Hope that helps. Bye.